This is the Satellite Foundational course for GOES-R on GOES-R aerosol products that are available in AWIPS and online. Doctors Kondragunta and Huff are major contributors to this task. I'm Scott Lindstrom from SIMS, and I'll be navigating your way through this training. What will you learn? That's shown here. Aerosol products, boxed in yellow, are just part of the many quantitative Level 2 products that are available from the GOES-R series of satellites. These baseline products are available in AWIPS under Derived Products, where you have the ability to select aerosol detection dust, aerosol detection smoke, and aerosol optical depth. Aerosol detection is produced for all three sectors: full disk, CONUS, and meso. Aerosol optical depth is not produced for mesoscale sectors. The temporal cadence for the imagery is also shown on this slide. These products are daytime only. The two aerosol products complement each other in some ways. Aerosol detection doesn't tell you anything about the amount of aerosols, for example. It simply tells you that certain types, dust or smoke, are present. Aerosol optical depth is a measure of the amount of all aerosols, but it says nothing about the type. The product creation was changed in 2024 to use the enterprise algorithm that works with both GOES and JPSS satellite input. Why do you need aerosol detection as available in the AWIPS menu? Aerosols affect the amount of radiation that hits the surface, which in turn will affect, for example, high temperature forecasts. Aerosol detection is important for air quality considerations and air quality forecasts. Many operational numerical models do not as yet include aerosol loading, although there are non-operational models that will predict aerosol motion, and you can find these online. The aerosol products give you information not routinely available in models available in AWIPS. For the purposes of this training, aerosol detection focuses on dust, smoke, and haze. Aerosol optical depth, AOD, measures the extinction, or the attenuation of light, due to scattering and absorption, so it's related to the number of aerosols in the column. AOD is very low with pristine air with clear skies, but the value can be large, up to near 5 or 6, for thick smoke events, but a lot of color bars will peak around 1. Visibility is definitely linked to AOD and extinction. The inset map shows AOD computed from NOAA 20. AOD can be affected by a variety of events as listed. The aerosol products are created using satellite observations of reflectance, so they are daytime-only products. They have 2-kilometer resolution. Values are not computed if clouds are present. Land is pretty reflective at some wavelengths, and that reflectance makes it a bit harder to detect aerosols over land relative to over water. When and where are these products produced? Quantitative estimates are limited to solar zenith angles of less than 70 degrees, which is the yellow band in the images of the GOES footprints. Be cautious using products at high zenith angles, where the results are only qualitative. This shows the 2 visible and 4 near-infrared channels on ABI that are used to discern reflectance from the surface and from aerosols. The thin line, that's gray, shows transmittance. Small amounts of scattering and absorption are present in bands 2, 3, 5, and 6. That is the red band at 0.64 micrometers, the veggie band at 0.86 micrometers, the snow ice band at 1.6 micrometers, and the cloud phase at 2.2 micrometers. The cirrus band, band 4 at 1.38 micrometers, is a region of strong absorption by water vapor, and the blue band, at 0.47 micrometers, is in a region of increased scattering. Differences in absorption and scattering by aerosols between all the bands helps algorithms identify the presence of the aerosol. Reflectance changes as a function of wavelength and surface type. That complicates aerosol detection over land. Are reflectance differences being driven by surface type or by aerosol? Aerosol detection over water is more straightforward. When computing AOD, the trick or challenge is to separate the effects of the surface, which is not so interesting, from the effect of the atmosphere, which is much more interesting. The effect of aerosols on reflected visible light varies by wavelength. The multispectral observing abilities of GOES-R in the visible and the near-infrared are key. Remember that this is daytime only, as noted already. Reflectance is driving the observations of aerosols and AOD. All visible and near-infrared bands are used with this product. Some infrared channels are used as well, especially for computing the cloud mask. You can find GOES-R aerosol products and other products useful for detecting aerosols and smoke at numerous sites online, such as at Aerosol Watch. Some of these show data from polar orbiters that don't have the temporal coverage of GOES, but have much higher spatial resolution, especially near the poles. There is also the HER smoke model that predicts aerosol, in the form of smoke, that coverage in the near term. Here is an older example of GOES-16 dust detection over the ocean. This is dust associated with a Saharan air layer outbreak. GOES-16 aerosol detection captured some, but not all of the event. And the dust RGB, shown here, better captured the large horizontal extent of the dust feature. The takeaway might be, use quantitative and qualitative products to estimate the coverage and intensity of a smoke or dust or aerosol outbreak. This slide lists some of the spectral tests used in the retrievals to detect smoke. These mostly include looking at a signal in one band and comparing it to a signal in a different band. Aerosol effects differ at different wavelengths. This is the power of multispectral observations. This shows aerosol detection of smoke in AWIPS in the upper right, aerosol optical depth in the upper left. The local satellite zenith angle limit is also showing up in these GOES-16 images from 2200 UTC on August 8, 2018. There's a nice correlation, as you might expect, between lots of smoke and high values of AOD. Here are the same suite of images from the following day when smoke was more widespread. Satellite detection has to be blended with surface detectors and models to ascertain whether the aerosols are near surface, where they'll affect health. But this smoke could certainly affect high temperature forecasts. Smoke is very apparent in true color imagery as well. Combine true color or geocolor with AOD to see where the most particulate matter is. In this case, AOD might not be computed over the northern plains if the smoke is thick enough to look like a cloud in the cloud mask. Some important points and reminders for this training. The last one is important. Always use as much information as you can gather to determine the spatial extent of an aerosol. Here's another example. This is a geocolor image approximating true color imagery. There's a dust plume over parts of Texas. If you look carefully enough, maybe you see 3 separate plumes. The dust RGB similarly highlights where dust is present, and it does show 3 separate plumes distinctly. AOD is shown here for the same case. The aerosol detection product is showing that dust is present, not smoke. Remember that none of these products are telling you what's happening at the surface. You'll need to find other information to decide on that. There is more information at these links that are available online. These links are also listed at the launching page for this training. Thank you for listening.